Hey everyone, welcome back. Ready to dive into some serious data analysis. Today, we're tackling something I know a lot of you are wrestling with, how to really get a grip on regression model evaluation.
Yeah, you've spent all that time building your model, but how do you know if it's actually any good?
Exactly.
Hmm.
And that's where these two little acronyms come in, RMSE and R squared. They're like the secret decoder rings for figuring out how well your models are actually working. I like that, decoder rings. It's like, once you have the key, you can unlock this whole new level of understanding about your data.
Totally. So let's break this down, starting with RMSE, which stands for root mean squared error.
RMSE, think of it like this, okay? You're trying to predict, let's say, coffee sales,
Yeah.
right? Based on the weather, maybe.
So you've got your model, it's spitting out predictions for how many cups you'll sell on a given day.
Right, but how far off are those predictions? I mean, is your model spot on? Or is it, like, way off in left field?
That's where RMSE comes in, right? It tells us, on average, how much our model's predictions are different from what actually happened.
Exactly. Think of it visually.
Yeah.
You've got your actual data points, and then you've got this line, your regression line, representing what your model predicted.
Okay, I'm picturing it. So RMSE is all about the distance between those actual data points and that prediction line.
Exactly. Those are our errors, those little distances.
Hmm.
And RMSE takes all those tiny errors, squares them, adds them up, divides by the total data points, and then bam, takes the square root.
So smaller RMSE, the closer our predictions are to reality.
You got it. A lower RMSE, like you said, means our model is doing a better job of hitting those predictions.
Okay, so how about we bring this to life with an example? Our listener sent in some code, and they're working with these data points, 1, 1, 2, 2, 2, 3, and 3, 6.
All right. So picture those data points scattered on a graph, and then imagine drawing a line through them. That's your regression line, right?
Okay, I'm with you.
Now remember those distances we were talking about between the actual points and the line. Those are our residuals, and we need those to calculate RMSE.
Right, I remember. So we find those residuals for each point, square them, sum them all up, divide by the total number of points, which in this case is 4.
And then last but not least, take that square root.
And that gives us our RMSE.
And the best part is this whole process, it scales. It doesn't matter if you have 4 data points or 4 million, the logic holds true.
Okay, that makes sense. But we can't just stop at RMSE, right? There's more to the story.
Yeah, we've got to talk about R squared. So we've covered how much our predictions are off, but now let's look at how well our model actually explains what's going on in the data.
All right, break that down for me. What do you mean by explains what's going on?
Okay, imagine you're a detective, right? You walk into a crime scene, and there are clues everywhere. Footprints, fingerprints, you name it. R squared is like figuring out how much of the crime those clues actually explain.
Hmm, interesting. So a higher R squared means our detective, or in this case, our model, has a better grasp on the situation.
Exactly. A higher R squared, something closer to 1, tells us that the variables our model is using are doing a good job of capturing those patterns in the data.
Okay, I'm following you. So in the code our listener sent over, the R squared came out to be 0.89285714285714229. What's that telling us?
That means almost 89.29% of the changes we see in, say, coffee sales can be explained by the variables in our model, whatever those might be, weather, day of the week.
Wow, that's actually pretty impressive.
It is. So to recap, we've got RMSE telling us how accurate our individual predictions are, and then we've got R squared giving us this big picture view of how well our model is explaining the data overall.
This is all starting to click now, I'm not going to lie. But here's the real question. How do we know if an RMSE or an R squared value is actually any good? Like, what's the magic number?
Ah, the million-dollar question, right? And you know what? It's trickier than you might think. There isn't really a magic number when it comes to these things.
Yeah, that's what I figured.
It all boils down to context.
So what might be a fantastic R squared in one scenario could be, like, totally unacceptable in another.
Exactly. If you're, like, predicting something like, I don't know, website traffic, right? A slightly higher RMSE, it might not be a huge deal.
Right, but if you're dealing with something with higher stakes, like medical diagnoses or financial forecasts,
Oh, even a tiny error.
it could be disastrous.
Exactly. It could throw everything off.
So how do we figure out what good enough looks like for our specific situation?
Well, you really have to understand the data itself, right? Like, what's the cost of being wrong? And how much improvement is actually achievable?
So it's like finding that balance between accuracy and practicality.
Yeah,
It's
exactly.
not always about chasing the absolute lowest RMSE or the highest R squared, is it?
Not at all.
It's about understanding the trade-off.
Exactly.
and making smart decisions based on what we're trying to achieve. Okay, so we've got these two powerful metrics, RMSE and R squared, and we know that context is king. What else do we need to keep in mind as we venture further into this world of model evaluation?
One thing that I think often gets overlooked is the power of visualization.
Oh, interesting.
Yeah, I mean, numbers are great.
They tell a story,
They do. But sometimes you need more.
like a picture.
A picture, exactly.
Okay, so what kind of visuals are we talking about here?
Well, a residual plot, for example, can be super insightful.
A residual plot? What's that?
It's basically a graph
Okay.
where you plot your residuals. Remember those, the prediction errors?
Yeah.
You plot those against the predicted values.
So we can actually see those gaps visually.
Exactly.
That's cool.
And you know what's really neat? The way those points are scattered on the plot, it can tell you a lot about how well your model is doing.
Really? Like what?
Well, if you see them kind of randomly scattered, it might mean your model is doing a good job.
But if there's a pattern,
Then that could be a sign that your model is missing something.
it's like those hidden image puzzles, right? You have to look at it in a different way to see the full picture.
I like that. You got it.
So we've got RMSE and R squared, our trusty metrics,
Right.
but we also have these visual tools like residual plots that can give us even more insights.
Absolutely. It's like having a whole toolbox.
Yeah.
Right? You need the right tool for the job.
So we've really gone deep on RMSE and R squared today.
Yeah.
We've learned what they are, how to interpret them, and even how to use them to troubleshoot our models.
And we've just scratched the surface,
It's
really.
like we've unlocked a whole new level of data analysis. But let's not get ahead of ourselves. We've thrown a lot of info at our listeners today.
Yeah, but it's easy to get lost in the weeds with this stuff.
Right. We've got RMSE, we've got R squared, we've even got residual plots.
A whole arsenal of tools.
But the key takeaway here, and I think this is important,
Oh, on.
it's not just about blindly calculating these things.
No, absolutely not.
It's about understanding what they mean.
Yes. And what they tell us about our models.
Exactly. So to our listeners out there, if you're just starting out with regression analysis, don't get overwhelmed. Focus on the fundamentals.
Start with RMSE and R squared. Get those under your belt.
Then dive into those visualizations. See what your data is trying to tell you.
And remember, there's always more to learn. This is a journey.
Exactly. So keep experimenting, keep asking those tough questions, and most importantly, have fun with it.
Because data science should be exciting.
It should be. It's about unlocking those hidden patterns, uncovering the stories within the data.
And who knows? You might just discover something amazing along the way.
You never know. And we'll be here to help you every step of the way. That's all the time we have for today, but keep those data fires burning.